It's called EVT. Remember anything like that?
I remember you telling us that was one of the three things, one of the three VTs.
No? Do you know, Matthew?
It's the Extrema value theorem.
Yeah. Extreme value theorem. Remember, there's three theorems. There's the mean value theorem that has to do with derivatives, and that's the only thing that has to deal with derivatives, MVT. And then we have something called the intermediate value theorem, and that depends on something called continuity, that the function's continuous. Anybody know what this was? Was that helpful that Matthew told you it was the extreme value theorem, Tyler? No? What about you, Jonah?
Does it depend on the extrema?
Yeah, it says if f of x is continuous, on a closed interval, there must be at least one absolute max. Well, I get to use my eraser. Max and min. Okay, guaranteed on a closed interval. Doesn't have to be differentiable, it's just got to be continuous on a closed interval. So I'll give you an example. Let's say right here is A, and right here is B, and here's an endpoint, here's an endpoint. Let's start here, go up, go down, go up, and go down. Now, the reason I put this sharp point in here because it's not differentiable at that point, and you've heard me say that many times, right? Here I have a nice smooth curve, it's differentiable there. I have another nice smooth curve, it's differentiable there. Right here I have a smooth curve, it's differentiable there, correct? Okay, so right here I could put a horizontal tangent line. Right here I could put a horizontal tangent line. Right here I could put a horizontal tangent line. So these are critical points. Those three are critical points for what reason? There's a reason I drew a horizontal line, Audrey. What's true at all horizontal lines? The derivative is equal to 0. So here I can say f prime equals 0, f prime equals 0, f prime equals 0. This, I'll make sure I don't go too fast. Grace, this also is a critical point. But it's not because the derivative is equal to 0. It's for another reason. Well, what is that reason? Because the derivative does not exist. A little bit of review. Everybody okay with that? And right here I have an endpoint. And right here I have an endpoint. Now, it's a continuous function or continuous curve on a closed interval, correct? So it has an absolute max. This spot right here would be the absolute max. It's easy to see. It's above all the other values, correct? It's the highest y value in that interval. This is a y value. Comes over here, you could say, hey, you give it a number, and you could say that y value is the highest value than all the others, right? And this endpoint is the absolute minimum. Why? It's the lowest y value compared to all the others. Everybody with me so far? Now, I don't know if you learned this in geometry, but when I used to teach geometry, I would say we had, when we ever would draw a line, you know, those things that were straight, okay, we would say they were dense. Do they ever talk about density in lines?
I do not recall.
Okay, so
that.
this is what density means. If I pick 2 points on a line, I can find a point in between them. Okay? And you can use the number line to express that. Like between the, you know, if I say, okay, because a number line, right, is a line. And I can say, okay, right here is going to be 0. I'll do it on, you don't have to write this down, but let's say I draw my line. Here's 0, here's 1. That's what I'm going to call those 2 points. Can I find a number between 0 and 1? Well, for sure, a half. Can I find a number between 0 and a half? Yeah, I can. And I can keep doing that forever and not have a gap to go through. Is that going to make sense? Because I'll hit a number in between there. And that's what we call density. All right? And so what I'm saying is, on this closed graph, there's an infinite number of y values. Would you agree? But in calculus, we can say we don't have to examine that infinite number of numbers to find the absolute max or min. They can only occur at 2 places. Either at these endpoints or
at the critical points.
At the critical points. Either at the endpoints or at the critical points. Is that kind of making sense? Because at these critical points, it's where they could possibly turn, or the graph could possibly turn direction and go the other direction, correct? So I had 2 endpoints, which you'll always have, and in this case I had 1, 2, 3, 4 critical points that I would have examined to find out which was the highest y or the lowest y. Am I making sense on this?
I think so, but how do we examine? Because are we going to give the natural equation, or are you just going to be given the derivative?
Maybe both.
Ooh,
Okay.
even better.
Okay, so the candidates for the absolute extrema, what are our possible solutions? Either critical points or endpoints. Remember, I'm going to draw a little arrow here. I don't know why, but I see it under my notes. On a continuous function, the absolute extreme, I'm going to write it right here, I guess. Can only be these points. That's it. So let's take a look at this. Now, notice the notation. sometimes you see the notation look like this. Everybody agree?
Yep.
I like this because it's shorter. I grew up with this. And you're going to see both of them on the AP exam. You should say, hey, it's closed. And it says, here I have a polynomial, so I know it's continuous, correct? All polynomials are continuous. Remember to show that you checked all the candidates. So this is the steps that I go through. I'm going to, first of all, put in a -1/2, and I'm going to put in 4. So what am I putting into F right now? What am I checking? The endpoints, right? I know those numbers. I can see them. -1/2, 4. And what am I putting into here? Because this gives me the Y values. F's whole purpose is to give you the output, whatever those Y values may be. Does everybody understand that? So I did it ahead of time, and the way I did it is, and I'm not going to have you figure it out, I took a -1/2, and I cubed it, and then I took a -1/2, and I squared it, multiplied it by 3, and then I added 1, and I came up with 1/8. And then I did the same thing with 4, I cubed it, and then I squared it, multiplied it by 2, and then added 1, and I came up with 17. Well, right now, my absolute max is 17, my absolute min is 1/8, correct? But I'm not done there, Callan. I have to find my critical points. And this is stuff that you did a long time ago when you first started learning about functions, right? When you took whatever algebra class you said and you plugged them in and you got the answer, right? So now is the calculus part. We're going to take the derivative. And Maria, what's the derivative?
3x² minus 6x.
And to find those values, we have to make it equal to what? 0. And 3x² minus 6x. I'm going to factor out 3x. Is that what you would do?
Yeah.
And would you get x minus 2? I'm just making sure I don't goof up. I've been goofing up lately, okay? So x equals 0 and x equals 2. Everybody okay? Now I'm going to give you a little bit of warning because I've been teaching long enough to know this is what people have done. And Ben, I hate to admit it, but it's going to be on the abyss forever until the abyss collapses and we all die, okay? I have made the mistake of putting 0 into here and 2 into here, and guess what answer I get? 0. And then I say, 0 is my absolute minimum. Well, no, this doesn't give me y, does it? It should give me 0, because I just determined what values give me a horizontal line, right? Where do I put 0 and where do I put 2? Over here into F. Because I want to know which is the highest y value and which is the lowest y value. Everybody following me? Okay, so I'm going to put 0 into here, and when I put 0 in there, 1. And when I put 2 into there, I had 2 cubed minus 3 times 2 squared plus 1. This was 8. 3 times 4 is 12. 8 minus 12 is a -4, and I got a -3. Now notice how I'm going to write my answer here. It says right here, the absolute maximum value. Y is the value. What number gave me that value? 2 or 4. Everybody understand that? But my maximum and my minimum value, I'm going to say my absolute minimum
or absolute minimum of whatever number
value,
at x equals.
right. But I'm just gonna say is a -3. My absolute maximum is 17. So we're just extending what we've been doing the last few days, right? Okay, I know that my function decreases, increases, decreases, increases, decreases. Now I'm going to say, okay, which of these I need to have it continuous, I need it to be a closed interval. Because if it's an open interval, it just goes on forever, right? It doesn't mean you can't, like a parabola either has an absolute max or an absolute min, right? That vertex. But we don't always have that. Okay, so now this looks a little bit different. And right now I'm writing the quiz, and this is a question that's going to be on the quiz. It's also a question you're going to see quite often on the AP exam. And so this is not F. It'll tell you, this is how it says. On the graph is F prime, which is the derivative of F. They will tell you that. And what will happen to somebody in here, because it's happened to me, I think it's F. Even though I've been told it's not F, it's the derivative of F. So these are all the slopes, correct? And this is the most important slope. Austin, why is the one I'm pointing to right here the most important slope? At x equals 1, the slope is what?
0?
0. In other words, it's a critical point, correct? Is it a relative minimum or maximum, or neither?
It's a maximum.
It is a maximum.
But I'm not 100% sure if it's the relative variety. It could be of the absolute. Because
Correct. We're gonna talk about that in a second. Okay.
And where x is 3, we get the relative minimum.
How do you know that?
Because it's going from negative to positive.
Yeah, I don't care what these values are. All along here, the derivative is positive, correct? So F is going up, isn't it? Would everybody agree? This whole interval from -3 to 1, F is going up. So I'm going to write that down. I'm going to say from -3 to 1, F is increasing. And from 1 to 3, F is decreasing. And then from 3 to 4, F is increasing. So this right here is a relative max, and this right here I know is a relative min at this moment. Does that make sense so far?
Yes.
All right. So, right here, I'm going to give you, and we're going to come back to this. So this is not, everybody's okay on this, correct?
Yep.
In these notes, this is the most important.
We cannot say that. What part is part 2?
Part 1.
Okay.
You need to know that. This is getting you ready for something down the road, okay? So if this is a little confusing to you right now, relax, okay? I'm going to turn this, and I'm going to draw a little picture. This is miles per hour. This is the number 1. This is the number 3. This is 60 miles per hour. And I'm just drawing that. So that means my car, my truck, because I drove my truck today, is on cruise at 60 miles per hour. And Austin, I'm driving by Fergus Falls. Wait, no. That's even a little bit too hilly. Okay, more like Moorhead. It's really flat by Moorhead, right? And what I'm trying to say, that cruise isn't changing at all. It's right there. Okay, and so this right here at 1 hour and at 60 miles an hour. At 2 hours, I'm at 60 miles an hour. At 3, I'm at, okay? And there's an area, I can make a rectangle underneath that, correct? And there's area underneath that. Does anybody know what that area is?
120,
How'd you get 120?
because it's 3 minus 1 times 60.
3 minus 1. And then 3 minus 1, that's 2. 2 what?
Whatever that label was.
Well, it was hours.
2 hours.
2 hours. And then you multiplied it by 60.
Would that just be 60 miles because the hours gets rid of the hours on the bottom?
And so the answer is what?
120
120 what?
miles.
120 miles. Okay, so now, in terms of calculus, this graph is above the x-axis, correct? Which means I'm going in one direction, correct? And did my distance increase because that's positive? It did, right? How much did it increase in those 2 hours? 120 miles. Now listen to what I said. It's above the x-axis. The area underneath that graph, right, this is a positive because it's above, right? So that means if this is a derivative, it means the function it came from is increasing, and the area underneath tells me how much it increased. It increased 120 miles. Everybody with me on that? So at 1 hour, Audrey, I don't know how far I've driven. I just know the next 2 hours I have driven 120 miles, correct? More. So at 3 hours, I have more than I did at 1 hour. Would you agree? I have 120 more. Would you agree? All right, now let's flip it back over. So this is a derivative, correct? I'm going to shade this. So this is the amount that f increased from -3 to 1. I know it increased because the derivative is positive, correct? So f of a -3, that's my endpoint, correct? Would everybody agree? I don't know what that is. I don't know. I could make up any number I wanted, Ella. Let me randomly think of it 3.
Yes.
Okay? Is f of 1 bigger than 3? It has to be, doesn't it? Because it increased till it got to 1. Would you agree with that? So f of 1 is greater than an f of -3. And I don't even know those numbers. And I don't even know how much bigger it is because it increased. Now, What's that represent? Well, I know that graph is underneath the curve, so f went down. Would you agree? And it went down this much. Would you agree? And that's f of 3. And here's f of 1. Right now I know f of 1 is my biggest value. Would you agree with that? Okay. Now, I got another critical point, correct? That critical point is 3, f of 3. Is f of 3 equal to 1? Is it, or f of 1, excuse me, if f of 3 equal to f of 1, is f of 3 less than f of 1? Is f of 3 bigger than f of 1?
How'd you get the y value of 1?
What?
How'd you get the y value of 3?
I don't have it. I have no idea.
But you're just doing hypothetical right now?
I'm saying, okay, these are the facts. I don't know what f of negative 3 is. But I do know, because the derivative is positive, f has increased, correct? Right? You told me it increased.
Yeah, but we got
Just
f of
wait.
3, we got
You-
f of 3 and an f of negative 3.
Right, but all I'm saying here is I know that f of 1 has to be bigger than f of negative 3. It has to be. Because f increased the entire interval. It can't be smaller. It can't be equal. It has to be more. Everybody following that? Now, here I'm at f of 3. How does f of 3 compare to f of 1?
Less than,
Why? I agree, it has to be less than.
because the, line is underneath the x-axis, so it's decreasing.
Correct. It's got to be less than this one because it went down. Would you agree? So right now, f of 1 is my absolute max. Would you agree? So I know this endpoint. Here are my two critical points. Here's my endpoint.
Trying to take a look. Let's see.
Okay. So now I'm going to compare f of 4 with f of 1. Right? Right now, f of 1 is the absolute max. Would everybody agree? Now, I increased. Right? Here's the amount of increase. Here's the amount of decrease. Here's the amount of increase. Is f of 4 bigger than f of 1, or is it less than f of 1? What? Why does it have to be less? You can't tell me that this area is bigger than the amount that decreased, correct? Right? It would have to be bigger than that amount to be bigger than f of 1, correct? Now, if it would went way up here, we'd have a different thing, but it just went up a little bit, didn't it? So that means f of 4 has to be f of 1. So my max so which two, there's two possible answers, which two could be my absolute min?
3 and negative 3.
F of negative 3 and f of 3, correct? Why? This is a relative min, correct? So I started at f of negative 3, I increased, then I decreased f of 3. So which is smaller, f of a negative 3 or f of 3?
F of negative 3,
Why?
because it goes up by more than it goes down.
Right, if you take a look at negative f of negative 3, this went up a whole bunch, didn't it? And for this f of 3 to be less than f of negative 3, this area below here has to be bigger than this area above.
So
Okay?
the
Let me pretend and just give it numbers. Let's say f of negative 3 is equal to number 3, and this area under here is 5. And this area is 2. Well, that means I would have went from 3, added 5, and got 8, and then went back 2 and be at 6. Right? I didn't go back. So f of negative 3 is the absolute min. Matthew.
So that means the bigger the area, the more the change?
Exactly. See what he said right there? The more the area, the bigger the change. That's exactly correct. The longer you stay, the bigger area you accumulate. When you're above or below the axis, the bigger the change.
Okay, so the one with the biggest area, the critical point that has the biggest area or endpoint is either the absolute max or min.
Correct.
So the endpoints of the part that has the biggest area has both the end and the
Well, you
has
get.
both the ABS of both.
Well, you take a look here. This was a critical point, right?
The endpoints of the part with the biggest area.
Oh yeah, I see what you're saying. You're saying this was an endpoint here.
Yeah.
Okay. Okay. You got to. Yeah, and it has to be. It has to be like a relative maximum or relative minimum. It has to cross.
Yes.
Do you understand what I'm saying? If this would have bounced back up, okay, it wouldn't be the absolute.
Because it didn't cross.
Correct.
But the endpoint of that thing, if it crosses.
Right. You're talking about the enclosed area.
Yeah.
Okay.
So
And I would
the
agree.
the end two endpoints of that enclosed area, if they cross, or one of them is the the end endpoint, those 2 points are going to be both our absolute values.
Yeah.
Okay.
Okay, so this right here, I'm just saying this right here, I won't test you on or quiz you on at this time. What we're going to do is we're talking about derivatives. Down the road, we'll be talking about antiderivatives. And the purpose of antiderivatives is to figure out the area underneath these curves and help us figure out what the amount of increase and the amount of decrease. Is that kind of making sense? So we're kind of setting you up there. This is what I want you to know for today. Okay? Does everybody understand that? Because this is getting to be pretty heady and it's hard to do when you have a picture, and we're going to be pulling it in. But it's going to